Take a look at this nested radical. It looks pretty intimidating, right? We have square roots inside square roots, and variables raised to the fourth power. But don't worry, there's an incredibly elegant way to simplify this. The trick is to not look at the whole thing at once, but to start from the inside out. To simplify a complicated square root, a very common trick is to check if the expression inside can be rewritten as a perfect square. Because if it is, the square and the square root will beautifully cancel each other out. Let's focus just on what's under the inner square root. 1 plus a squared plus a to the fourth. This looks almost like a perfect square. If only that middle term was a 2a squared. Well, we can make it that way. Let's add an a squared, and to keep things equal, subtract an a squared. Now, the first three terms form a perfect square, a squared plus 1 squared. And we are subtracting a squared. This is a classic difference of squares. We can factor it into a squared plus 1 plus a times a squared plus 1 minus a. Let's rearrange the terms a bit to make them look neater. Writing these long polynomials over and over can get messy. So, let's give them nicknames. We'll call the first one u and the second one v. This means our inner expression is simply u times v. But look at what happens if we add u and v together. The a and negative cancel out, leaving us with 2a squared plus 2, or 2 times the quantity a squared plus 1. If we divide by 2, we find that a squared plus 1 is exactly equal to u plus v divided by 2. Notice anything familiar? That's the exact expression we had in the first part of our radical. Now, we can swap out the messy algebra for our clean variables u and v. The first part becomes u plus v over 2, and the inner part becomes u times v. Let's find a common denominator to combine these into a single fraction. We get u plus v plus 2 root uv, all divided by 2. Look very closely at that numerator. Does u plus 2 root u root v plus v remind you of anything? If you treat u as the square of root u, it's a perfect square. It is exactly root u plus root v, all squared. And since we're taking the square root of that whole thing, the square and the square root cancel each other out beautifully. Our massive nested radical collapses down to just root u plus root v over root 2. For our final step, all we have to do is remember what u and v stand for. Let's substitute our polynomials back in. And there we have it. We've turned a complicated nested radical with fourth powers into a much simpler sum of two square roots. Mathematics at its most elegant.